Good evening, students. Welcome to Shruti Academy. So let us start with the question number 17, 18, 19, 20 of exercise 7.2 of chapter 7 for class 12 CBSE NCERT. So we need to integrate with the method of substitution over here. So the question number 17 is x to the power e to the power x square. Okay. So we need to integrate this with respect to dx. But if we see over here, there are two functions. First function is x, the second function is e to the power x square, and x square is also yet another function. So it becomes very typical to integrate it. So the method which is used in such type of questions is the method of substitution. So we will be assuming x square to be equal to t or some other variable. You can assume it any of the variable. So we will be assuming x square to be t. Then we will be differentiating this. X square is equal to t, differentiating with respect to x. So here we will be getting 2x dx. 2x. Over here we will be getting 2x. When we will be differentiating x square, we will be getting 2x, x to the power 2 minus 1. So that will be 2x. And over here it is dt over dx. So this dx will go this side with the multiplication. So it will become 2x dx is equals to dt. So now in this expression, x dx can be easily substituted by x dx can be easily substituted by dt by 2. dt by 2. Okay. So we can replace this, and we know that x square is t. So 1 upon e to the power t. It will become 1 upon e to the power t. So I am writing over here, it will become 1 upon e to the power t dt upon 2. Okay. So it will be equal to 1 upon 2 integration e to the power minus t dt. So now our whole expression is in terms of t. Okay. And we need to integrate this with respect to t over here. Okay. So it will become, when e to the power t is integrated, it is e to the power t only, but it is having a minus 1 with the multiplication. So that will come with the division, because we have to integrate e to the power minus t over here. So when we will be integrating it, it will be 1 upon 2 e to the power minus t upon minus 1 plus c. Okay. So we cannot leave the answer in the t variable. Okay, we need to still integrate it. We need to still integrate it. So after integrate, we need to re-substitute it. Okay. So it will become 1 upon 2 with a negative sign and e to the power x square, e to the power minus x square plus c as our answer. Okay. So what basically we did, we first substituted x square is equals to t. We differentiated it. So we got 2x is equals to dt over dx. Then dx got multiplied with 2x. So it became 2x dx is equals to dt. So x dx will be equal to dt by 2. Okay. So now we substituted x dx to be dt by 2, and it over here it was 1 upon e to the power t. So 1 upon e to the power t can be written as e to the power minus t. So when e to the power minus t got integrated, it became over here, it came over here 1 upon 2 e to the power minus t upon minus 1 plus c. Okay. So we cannot leave the answer in the variable t, because in the question we were asked for x. So I resubstituted it, and so now my answer is minus 1 upon 2, because minus 1 into 2 will give me minus 1 upon 2 e to the power minus sign will be there, and in the place of t we can substitute x square. So it will be e to the power minus x square, or you can also write minus 1 upon 2 1 upon e to the power x square plus c as your answer. Okay. So now let us proceed to the question number 18. In the question number 18 also we will be applying the method of substitution. So this is also has to be integrated with respect to x. Okay. So we will be substituting over here tan inverse x to be equal to t. Okay. So when you will be substituting tan inverse x to be equal to t, so when differentiating with respect to x, so you will be getting over here 1 upon 1 plus x square. Tan inverse x, differentiation of tan inverse x is 1 upon 1 plus x square equal to dt over dx, will be equal to dt over dx. So dx will get multiplied over here. So it will become now dx upon 1 plus x square will be equal to dt, will be equal to dt. Okay. So this we have got. So in the expression it is 1 upon x square. So 1 upon x square dx can be substituted to dt directly. Okay. So integration of e to the power tan inverse x into 1 upon 1 plus x square dx. So this whole thing can be substituted to dt. Okay, this thing can be substituted to dt, and e to the power tan inverse x will become e to the power t dt. Okay, so here we will be getting over here integration of e to the power t dt, and it is now very easy to integrate e to the power t. In spite of this whole expression, it was typical to integrate it, but with the method of substitution it became so easy. So e to the power t when integrated will be e to the power t only plus a constant, that is the integration constant. So I cannot leave the answer in the terms of t. I have to resubstitute the value of t which I have already assumed earlier. So e to the power t will be e to the power tan inverse x plus c. So this is my answer. Okay. So now let us move ahead towards the question number 19. So in the question number 19, it is e to the power 2x minus 1 upon e to the power 2x plus 1. So right now we need to do some manipulation over here, because if I am going to substitute e to the power 2x plus 1, I will be not getting e to the power 2x minus 1 as dx to be substituted to dt. I will be not getting anything to be substitutions, because all the terms of x should be substituted in the variable of t which we are assuming. Okay, so I'll be manipulating this. What manipulation we can do? We can do one thing. We can divide the numerator and denominator by e to the power x. So we can do this definitely. We can dividing numerator and denominator by e to the power x. Okay, so now it became e to the power 2x minus 1 upon e to the power x whole upon e to the power 2x plus 1 upon e to the power x. Okay, So when e to the power x is divided by both the terms, so e to the power 2x minus e to the power x minus x, when this e to the power x will go to the numerator, it will go with a negative sign. So the powers are subtracted over here. So it will become e to the power 2x minus x will be e to the power x minus e to the power minus x upon e to the power 2x minus x will be e to the power x plus e to the power minus x. Okay, so now I can easily substitute this e to the power x plus e to the power minus x to be some variable. So I am substituting over here to be variable to be t. So let us see over here. So I am assuming it to be e to the power x plus e to the power minus x to be equal to t. So from here, if I differentiate the whole equation with respect to x, so it will be e to the power x itself, and over here it will be e to the power minus x plus minus 1 multiplied. Okay, and over here it will be dt over dx. So e to the power x minus e to the power minus x dx will be equal to dt. So this is clear. Over here. Okay. So e to the power x minus e to the power minus x dx, this whole can be substituted to this whole dx can be substituted to dt. So now it will become integration of dt upon t. Okay, and 1 upon t, the integration of 1 upon t is log t. So when it is integrated with respect to t, I will be getting over here log t plus c as my answer. So log of t, I have to resubstitute the value which I have substituted over here in terms of x. So it was e to the power x plus e to the power minus x, okay, plus c. So this will be my answer. Okay, so the main thing is that the substitution should be proper. If the substitution is proper, the answer will be automatically correct. Okay, so now let us move ahead towards the question number 20. So in the question number 20, it is we need not to do any manipulation. It is same as question number 19. The only difference is that over here it is e to the power 2x instead of e to the power x. In the question number 19, we have to do some manipulation and then we solve the question. Here if we differentiate e to the power 2x plus e to the power minus 2x, we'll be getting over here the value. We'll be getting this term, this term to be substituted to dt. So let us look what we are getting over here. So let us assume e to the power 2x plus e to the power minus 2x to be equal to some variable t, differentiating with respect to x. So we'll be getting over here e to the power 2x. When the e to the power 2x differentiated, we'll be getting over here e to the power 2x, and also again chain rule differentiation of 2x. So 1, 2 multiplied over here. Okay, plus e to the power minus 2x and minus 2 multiplied rather with over here, because the chain rule says all the leftover are again differentiated. The 2x is again a function, so it should be differentiated. The chain rule says, so when 2x is differentiated, we'll be getting 2x minus 2. sorry, we'll be getting minus 2 over here. So, and over here we'll be getting dt over dx. We'll be getting dt over dx. Okay, so now from here we can take 2 as common. So we are taking 2 as common. So it will be e to the power 2x minus e to the power minus 2x dx to be equal to dt. Okay, so from here e to the power 2x minus e to the power minus 2x will be equal to dt upon 2. This 2 will go that side, so it will go with the division. So it will go with the division. Okay. So we have got over here e to the power 2x minus e to the power minus 2x. So this whole thing can be substituted by dt over 2. Okay. So our expression will now become as 1 upon t dt upon 2. So 1 upon 2 is a constant. It will come out of the integration. It can easily come out of the integration. So we'll be getting 1 upon 2 integration 1 upon t dt. So 1 upon t, we already know the integration of 1 upon t or 1 upon x is log x or log t. So it will be 1 upon 2 log mod t plus c. So resubstituting the value of t over here, we'll be getting 1 upon 2 log of e to the power 2x plus e to the power minus 2x, okay, plus c. C is the integration constant which we need to apply over here. Okay, so C is the integration constant that already comes in the integration, and the answer which we are getting over here is this. Okay, so this is our answer. So the answer is 1 upon 2 log e to the power 2x plus e to the power minus 2x plus c. So this is the how we need to apply. If there is nothing to be substituted, then like we are substituting and we are not getting any substitution, what to substitute dx? We cannot remove dx. Removing dx is a troublesome for us. Then in that case, we should do some of the manipulation. We should think over it. We should think and we should do the manipulation. So here, what manipulation has to be done? Dividing the numerator and denominator by e to the power x. So after the manipulation, I easily got the substitution. I substituted e to the power x plus e to the power minus x to be d over here, and then I differentiated, so I easily got e to the power x minus e to the power minus dx to be dt. And so I substituted it to be dt and further solve the question. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.